Okay, in lesson 10.2, we're going to be learning about all the product of powers properties. So in the key ideas in your book, you'll see a few things. There's a lot of them. We're actually going to go over 3 of them. We're talking about the products today. So the first one, the product of powers, okay? It's when you multiply powers with the same base. You simply add their exponents. So if you notice, we have 4 squared times 4 cubed. If we were to write this out, it would look like 4 times 4 for the 4 squared. Then there's 3 factors, 1, 2, 3, so that you can see in total we have 5 factors of 4. So when the base is the same, there's no need to evaluate. You are not being asked to evaluate. You're being asked to simplify today. So you look to see that the base is the same. If the base is the same and they're being multiplied, you add the exponents. Okay? And if you need to, write it out as the repeated multiplication and then, count them or add them that way, you can see that that's true. Also note that we're not being asked to even multiply 4 times 4 and put that to the 5th power. That's a common misconception, but 4 to the 5th is not equal to 16 to the 5th, and you would agree. In the next one, it is said to be the power of a power. So now we have a base with an exponent that is being raised to an exponent. So remember that when you look at an exponent, it is telling you the number of times, oh, I wrote that a little bit too much, that a base is being repeated. So the base in this case is 4 to the 6th. So 4 to the 6th power times 4 to the 6th power times 4 to the 6th power, which now makes it look a lot like the first one. We have 6 factors of 4 times 6 factors of 4 times 6 factors of 4. So how many factors of 4 do we have altogether? 18. And how you could get that from the original problem is if you see that a power is being raised to a power, you can multiply them. So maybe hopefully it makes it easy to see that usually you'll have the parentheses, almost always you'll have the parentheses. So you can see that parentheses means multiplication, so that hopefully will help you remember that you multiply 6 times 3. Okay, the final property that we're looking at today is the power of a product. So sometimes in the parentheses you will have 2 numbers being multiplied, and that whole thing will be to the 5th power. So it's kind of like we can distribute the 5 and be an exponent of each base. So 3 to the 5th power times 2 to the 5th power. Okay, so to simplify this, you would apply that exponent to each of the factors inside the parentheses. All right, seeing the algebra, a lot of times we see it like this even, ab raised to a power. In this case, the exponent is m, so a to the m times b to the m. All right, again, we're not being asked to evaluate. You are simply being asked to simplify. So looking at the first one, a, 2 to the 4th times 2 to the 5th, we can add the exponents to get 2 to the 9th. In b, when we have negative 5, there's 1 factor of 5, and then negative 5 to the 6th power, we have 6 factors of 5. How many factors of 5 in all? The answer is 7. So please do not neglect, and I always encourage students to write in an exponent of 1 when you do not see one. But also keep in mind that this base and this base must be the same. If this happened to have been a positive 5, it is not the same as a negative 5. So the bases are the same. That's what makes this property usable. For C, if it's a variable base and it's the same letter, so x cubed times x to the 7th gives us 10 factors of x. So let's try it out. If we are asked to simplify this expression Note that the base is the same. We have 6, and we can add together the exponents to get 6 to the 6th power. Again, we are not being asked to evaluate. Simplify. In 2, again, examine the bases. A -1/2 and a -1/2 are exactly the same. Therefore, since we have 3 factors and 6 factors that are all going to be factors, 3 plus 6 gives us a -1/2 to the 9th. So again, you would add the exponents to show your work. 3 plus 6. Okay? And for 3, again, we will take z to the 1 plus 12 power, or z to the 13th power. Finding a power of a power. Again, you will note this because you'll see the parentheses and then another exponent. So 3 to the 4th power is the base. It is a factor 3 times. So we have 3 to the 4th times 3 to the 4th times 3 to the 4th. We can simplify. Instead of adding 4 plus 4 plus 4, we could multiply 4 times 3 and get 12. For b, w to the 5th power raised to the 4th power, 5 times 4 is 20. So let's try it. In this case, 4 to the 4th power is the base. It is a factor 3 times. It would look like this. So we can take 4 to the 4 times 3, or 4 to the 12th. Y squared to the 4th power. It's a factor 4 times. We would get 8. Y to the 8th power. In this case, the base is a -4. It's being cubed, and so -4 to the cubed is the base. It's a factor twice. So there are actually 6 factors of -4, because we will take the -4 3 times 2 to give us -4, keep the parentheses, to the 6th power. And finally, finding the power of a product. So in a way, we're just distributing the exponent to each factor inside the parentheses. So 2 cubed times x cubed. In this case, to simplify, they're allowing you to go ahead and evaluate the answer, 8x cubed. That's fine, okay? Because that definitely does simplify it when you have the number part as the coefficient. So 3 squared times x squared times y squared would become 9x squared y squared. So let's try it. So we're distributing this. 5 to the 4th, y to the 4th. When you take 5 to the 4th power, you'll get 625 y to the 4th. Okay? For 8, as simplified as we can get, because they are variables, but we are applying the exponent to both. And for 9, so when we take 1/2 and we square it, we get 0.25. M squared n squared. Another way to write it is 1/4 m squared n squared. Either way, but if it gives it to you in a decimal, I'll allow you to keep it in a decimal form.